The world cheered when the first Apollo crew set foot upon the moon and returned safely to Earth. Buzz Aldrin, Neil Armstrong, and Mike Collins had fulfilled one of the most audacious dreams in the history of human exploration. The exploits of the Apollo astronauts were well known. Few knew at the time that what they saw, what they found, would touch off a chain reaction in science, delivering a new understanding of how the planets formed, how the moon was born, and how Earth and life emerged. These findings, along with the recent discovery of water on the moon, are rebooting Apollo's loftiest vision: to launch new generations of human exploration. Six times in 4.5 years, Apollo spacecraft will coast over a pocked lunar surface and descend onto dusty plains. "12 astronauts will climb out to experience the moon up close. On tightly choreographed excursions, they set up experiments, made measurements, and collected rocks as they walked or drove across the alien terrain. These heroic missions teased a daring new era of exploration and achievement. The investment poured into researching how to get safely to and from the moon would act as an accelerant for technologies that increasingly shape modern life: computation, communications, electronics, robotics. But it's the science produced in the wake of Apollo that will increasingly define its legacy. The quest to study the moon was a fundamental goal of the space age. The Soviets developed the giant N-1 launcher, intended to send cosmonauts beyond Earth orbit. The N-1 never succeeded in any of its 4 launches. Its second attempt crashed back in one of the largest ever human-made non-nuclear explosions. The American lunar program pinned its hopes on the mighty Saturn V rocket.
We shall send to the moon, 240,000 miles away from the control station in Houston, a giant rocket more than 300 feet tall, made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communications, food, and survival on an untried mission to an unknown celestial body and do all this, and do all this, and do it right.
In 13 launches, the US heavy lift launch vehicle never failed to safely deliver its payload. The first human-rated launch carried the Apollo 8 command module into lunar orbit.
Roger, safe journey, guys. We'll see you on the other side.
Alone, behind the moon and out of touch with Earth, Apollo 8 astronauts fired their single engine, proving the critical maneuver for American missions to return.
Oh my God, look at that picture over there. Earth coming up. Wow, is that pretty?
This moonshot gave a war-weary, conflict-ridden United States something to cheer about and set the stage for humankind's greatest adventure.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
On July the 16th, Apollo 11 blasts off.
Tower cleared.
Okay, we got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading.
Neil Armstrong serves as the mission commander. Buzz Aldrin would pilot the lunar module, Eagle, down to the moon's surface. Michael Collins pilots the command module. It takes 3 days for Apollo 11 to cross the nearly 400,000 kilometers between Earth and Moon. On July the 19th, Collins fires the command module's rockets, and Apollo 11 enters lunar orbit.
Well, there is some rough country over there. Something really peppered that one.
The next day, Armstrong and Aldrin enter the Eagle lander to begin their descent.
You can't take it easy on the lunar surface right here. You have to be bumping almost that pitch. Okay, Mike.
Spurious radar data flood the lunar module's computer, triggering 5 separate alarms.
Okay, everybody, let's hang tight and look for landing radar.
We'll need that landing radar by 18,000 with this downtrack. Program alarm.
1202. 1202.
Give us a reading on the 1202 program alarm. We're going that flight. If it doesn't reoccur, we'll be go. He's taking it at up H.
Roger, we got you. We're going that alarm.
Each time, Mission Control deems it safe to press on.
Okay, all flight controllers, go for landing. Retro. Go. Fido. Go. Guidance. Go. Control. Go. Telcom. Go. GNC. Go. Ecom. Go. Surgeon. Go. Capcom, we're go for landing. Eagle Houston, you're go for landing. Over.
The moon's gravity is uneven. That causes the Eagle lander to pick up some extra velocity.
Your tag done for non-velocity. Standard speed down 3.5. 47 forward.
The astronauts sail past their ideal landing zone.
4.5 down. 5.5 down.
Flying above a field of boulders as big as houses and running low on fuel, Armstrong takes manual control, searching for a clean spot to touch down.
100 feet, 3.5 down, 9 forward. 5%. 75. 75 feet. There's looking good, down a half. 60 seconds. 60 seconds. Lights on. Down 2.5. Forward. 20 feet, down 2.5. Picking up some dust. 3 feet, 2.5 down. Big shadow. And after 30. 4 forward. 4 forward, just into the right a little. 30. 30 seconds. 1.5. 30 seconds forward. Good. Okay. Contact light. Okay, engine stop. ATA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 113 is in. We copy you down, Eagle. Tranquility Base here. The Eagle has landed.
About 6.5 hours later, Neil and Buzz set foot upon the moon.
The surface appears to be very fine-grained as you get close to it. It's almost like a powder. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind. Okay, gonna get the contingency sample there in here.
Armstrong quickly grabs a contingency sample.
I'll try to get a rock in here. A couple.
If they should have to leave quickly, they won't go home empty-handed.
It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here.
Armstrong and Aldrin now set out to gather rocks and lunar soil, the first samples plucked by human hands from the surface of the moon. The astronauts find themselves on a strange grey world, filled with optical illusions and unexpected juxtapositions. With no atmosphere to diffuse it, the sunlight is harsh, with shadows cast in deep black.
If I look around the area, the contrast in general is completely by virtue of the shadows.
Only the lander, the experimental gear, and the Earth offer swatches of color.
Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you. Over.
Aldrin places a seismometer, beginning a long study of the moon's interior. Recordings of myriad moonquakes show us that even today, as heat from the moon's formation slowly dissipates, Earth's companion is steadily shrinking.
Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation. Hey Neil, didn't I say we might see some purple rocks? Find a purple rock? Yep. Anything more before I head on up? Head on up the ladder, Buzz. Adios, amigos. Hey.
The first Apollo crew lifted off the moon aboard the Eagle lander with 2 boxes of lunar rocks and dirt weighing 21.55 kilograms.
I'm showing a good bit out of plane velocity on my cross pointers, Mike.
Roger, I have no indication of it.
Okay, Mike, I'll get in position here, and then you got it.
Just under 4 hours later, they docked with the command module Columbia for the journey home. Over the next 4 decades, Apollo samples would take scientists back in time, helping them to piece together one of the most dramatic stories ever told. The birth of the Moon and the rise of planet Earth as we know it today. Among the major findings of the Apollo missions is that rocks from Earth and the Moon share particular forms of oxygen that scientists regard as blood types for solar system bodies. This means the two worlds must share a common history. A picture of the Moon's deep past began to emerge, some of it written right on its face. Several large old craters are surrounded by concentric rings. You can see them in this image of a feature called the Mare Orientale. These circles are of the type that might have been created had a giant impactor splashed down long ago on a roiling red-hot liquid surface. The first people on the Moon encountered relatively light rocks strewn about the landing site, probably forced upward by heavier material sinking toward the Moon's core. These clues suggest that early in its history, the Moon's surface was a vast ocean of molten magma. The second Apollo mission would bring this idea into sharp relief. November the 19th, 1969. Pete Conrad and Alan Bean descend toward a region called Oceanus Procellarum, or Ocean of Storms. This vast plain is covered in a thick layer of solidified magma, perhaps unleashed by a large ancient impact.
Very good, very good. Looks good, Pete. Hey, there it is. There it is. Son of a gun, right down the middle of the road. Outstanding. 42 degrees, Pete.
They're homing in on Surveyor 3, a robotic lander that touched down in April 1967. The idea is to get within walking distance, but not so close that it covers Surveyor with dust.
You're looking good. Hey, look at that crater right where it's supposed to be. Hey, you're beautiful. 257 feet coming down at 5.
Conrad decides to come down 177 meters short of Pete's parking lot to avoid rough terrain ahead, but still a safe 360 meters from Surveyor.
Coming down at 2, Pete. You got plenty of gas, dude. Hang in there. 30 seconds. 18 feet coming down at 2. He's got it made. Come on in there. Contact light.
Roger, copy contact.
Okay. Engine room off. Okay. The brakes are closed. Good landing. Pete, outstanding, man.
Now on the Moon, they unmount Surveyor's TV camera and other parts to take back for analysis. Later, the detection of Streptococcus bacteria on Surveyor's parts will suggest that microbes can survive years in space. This leads NASA to purposely destroy the Galileo mission to Jupiter in 2003 and the Cassini mission to Saturn in 2017 to avoid contaminating moons that may be ripe for life. On the lunar surface, Conrad and Bean pick up a rock eventually nicknamed Creep for its constituents: potassium, rare earth elements, and phosphorus. These highland specimens are a rock type called anorthosite. A product of a molten surface, its presence is another clue to the origin of the Moon. Before Apollo, Scientists entertained a range of theories on where the moon came from. It's a protoplanet snagged by Earth as it passed by, or that formed right alongside the Earth at the same time. It's what remains of debris scattered by an asteroid large enough to carve out the Pacific Ocean. Or from rocks that exploded into space when radioactive materials sunk to the center of the Earth. The 12 people who walked the lunar surface saw nothing that could by itself solve the mystery of the moon's formation. Had they left with only photographs and memories, we might never know. Instead, they brought home rocks and made meticulous records of their context. Those rocks take us back to a time 4.5 billion years ago. Within the kingdom of the sun, a gravitational battle rages amongst nascent planets. A young, hot Earth is growing slowly, drawing asteroids and dust into its body. A protoplanet the size of Mars crosses its path. It has an iron core and a silicate mantle. Theia is on a collision course with Earth. As this computer simulation shows, it deals a glancing blow, tearing away about 1/3 of Earth's mass and leaving the remainder spinning rapidly. The impact envelops Earth in a dense atmosphere of super-hot vaporized rock. Much of the wreckage falls back in a rain of fiery impactors. About 1/100th of Earth's former mass now lies in a disk, eventually settling into a lumpy ring. This debris ring gradually breaks up. And over about a century's time, coalesces into a single sphere. The surface of this new moon is a hot magma ocean. A northocite rock floats to the surface, slowly hardening into a crust. For hundreds of millions of years, that crust will be battered by impacts large and small. The craters we see today bear witness to this violent age. $4.51 billion years after the moon was born, explorers would step onto this surface on a journey into its past and into that of Earth. Apollo 14's Alan Shepard and Ed Mitchell step into a confusing realm littered with ancient creep rock specimens. They head toward the rim of Cone Crater, on the hunt for rocks from the lunar interior blasted out by an impact. Many contain chemical traces of multiple impact events, in which rocks melt and recombine to make mashups known as breccias. Unlike Earth, where weather and erosion have erased evidence of all but the largest impacts, the Moon retains a detailed record of bombardment. In myriad craters, boulders, jagged rocks and lunar bedrock smashed into fine powder. Filmed from Apollo missions shows astronauts bouncing along with seeming ease in the low lunar gravity. In reality, exploring the Moon is hard work. Spacesuits, made rigid by the very air the astronauts need to breathe, restrict bending at the waist, knees and elbows. Yet these soldiers of science were tasked with maneuvering complex instruments.
No, dadgummit.
With chipping off and picking up rocks.
Okay, babe. Open the bag.
And with driving core tubes down into ancient, densely compacted soil.
Whoop. Okay. We see that one went all the way in. Not quite.
Well, I can't get over those lineations, that layering in Mount Hadley. Boy, I can't either. That's really spectacular. It's beautiful.
On the next mission, Apollo 15, the astronauts are given electric drills to take deeper core samples.
It's a great massage. I'm not putting any force on it at all. It pulls itself down in.
NASA has ramped up its science goals, so the surface stay time is extended. Dave Scott and Jim Irwin complete 18 hours of moonwalking and moon driving in the first powered lunar rover.
Okay, Joe, I'm going to put the TV on the rover now. Cable's connected.
Wheeled mobility proves key to the scientific bounty.
Okay, we're heading 320, bearing 350, and range is 4.3. Man, that's the most organized mountain I've ever seen. Yeah, they're so uniform in width, you know.
Their landing site lies near a collapsed lava tube called Hadley Rill.
5.2, 3,000 feet. 5.2.
It's a huge extrusion of hot magma that wormed its way across the surface, then cooled and hardened. Later on, the roof collapsed, exposing its hollow interior.
Oh, look at those large blocks on that west wall.
This long, sinuous conduit is similar to features made by volcanoes here on Earth. But Hadley Rill is much larger, 135 kilometers long, thanks to the Moon's much lower gravity. Lava tubes like this could make naturally shielded habitats for future lunar citizens.
Look at that. Guess what we just found? Guess what we just found? I think we found what we came for.
Bag it up.
During their second excursion, the crew collects sample number 15415, an object that comes to be called the Genesis Rock. It takes scientists back 4 billion years, to a time when the Moon's surface was being pounded by giant asteroids and comets. The craters left by these clashes, still visible today, are a record of the pummeling Earth would have endured in the same period. This barrage of material is thought to be a main source for the water that dominates the surface of our planet. The next moonshot pushes deeper into this ancient period.
Okay, fuel is good, 10%. That comes the shadow. Perfect place over here, John. A couple of big boulders. Down at 3, looking super. Give me 1 click up. You're backing up slightly. Okay, 2 down. Stand by for contact.
Apollo 16 touches down in a region far from previous landings to get better triangulation on seismic data and to explore higher elevation terrain. Until Apollo, most theorists believed the lunar highlands were built by ancient volcanoes. Astronauts John Young and Charlie Duke quickly cast doubt on this hypothesis. In more than 20 hours of prospecting, the pair finds almost nothing of volcanic origin. Instead, the surface of the moon appears to be all about impacts. Duke and Young bagged 2 samples that will turn out to be the largest and oldest found, 4.44 billion years, almost as old as the moon itself.
Pitchover's on time.
Roger, we saw lift off.
What a ride, what a ride. With a glare shield really comes in handy.
Beginning on Apollo 15, every ship has carried lunar mapping and panoramic cameras mounted outside.
I'm at the mapping camera, and the stellar cover door is open, and it's jammed against the handrail.
It's the command module pilot's job to retrieve film cassettes, because the service module will be jettisoned before re-entering Earth's atmosphere.
Okay, here comes the mapping camera cover. Sandhill moons out there.
In the darkness of space, more than 315,000 kilometers from Earth, astronauts Al Worden, Ken Mattingly, and Ronald Evans will each see the moon shrink behind them as they rush toward Earth at more than 4,800 kilometers per hour.
That's her, babe. Right off the nose.
The last Apollo targets a region where ancient and infant geology intersect. It is named Taurus Littrow.
Okay, stand by for pitch over. Oh, are we coming in? Oh, baby. Pitch there over. It is. Proceeded. And there it is, Houston. There's Camelot. Wide on target. I see it.
Dellinger, you're go for landing.
Onto this mix of old and new terrain steps the Apollo program's first and only practicing scientist, geologist Harrison Jack Schmitt. The youngest material here comes from a huge crater far away. The bright feature, called Tycho, known as the belly button of the moon. Analysis confirms that Tycho is the product of an asteroid strike 108 million years ago, very recent compared to the age of the moon.
Oh, hey! There is orange soil. Well, don't move it till I see it. It's all over. Orange. Crazy.
Schmidt and his fellow moonwalker and mission commander Eugene Cernan also find particles of glass created in an ancient explosive eruption.
I've got to dig a trench, Houston. Fantastic, sports fans.
But is the moon still volcanically active today? To help find out, Apollo 17 has brought the first gravity measuring instrument, the transverse gravimeter, to give scientists a picture of what lies beneath the surface. The crew drills 3 meters down and 3.8 million years back into the lunar crust.
What am I doing down in here? What were you doing down in there? She's going in like she's into pre-dead stuff. I'm not putting too much pressure on it. Oh boy, the old fingers really suffer on these.
The 111 kilograms of cylindrical core sections they bring back to Earth will tell a story of hot rock 200 kilometers below in the basement of the moon. By the time the last Apollo astronauts splashed down, the glow of Apollo had already begun to fade. Fearing the embarrassment of a catastrophe in space, the Nixon White House cancelled the last 3 Apollo missions. But the Apollo program left an indelible scientific and cultural footprint. Space has come to symbolize human ambition. An Apollo Saturn rocket upper stage was converted and launched as Skylab. NASA went on to build a partially reusable system to shuttle astronauts into low Earth orbit. The spacefaring nations built the International Space Station to encourage political stability and prove cooperation. Work on board ISS has advanced life support technologies. Meanwhile, private entrepreneurs launched satellites, building a robust industry supplying communications and navigation services. Still embracing exploration, public agencies led by NASA sent waves of robotic probes deep into the solar system. Two of them, the twin Voyager probes, have now ventured into interstellar space. Space-based observatories, like the Hubble Space Telescope, projected our eyes and minds out into the universe at large. As this golden age of astronomy unfolded, it sparked a host of new questions for scientists laboring over bags of rocks and dirt brought back from the moon. The giant impact theory became the starting point for a rethinking of the Earth-Moon relationship. In 2017, researchers applied new radioisotope dating techniques to samples from 1971's Apollo 14 mission.
I say, Houston, that most of these boulders are the same brownish gray that we found, but we see one is definitely almost white in color, a very definite difference in color, which we'll document. We notice that beneath this dark brown regolith, there is a very light brown layer.
This work placed the Moon's birth at 4.51 billion years ago, fixing a date for an age of colliding protoplanets that built the solar system we see today. If the Moon had been born much later, there would not have been enough time for the planet to cool and for life to arise some 400 million years later. According to theory, Theia struck at an off angle. That would have given Earth its tilt and set it spinning at a rate of once every 5 hours. Over the eons, as the Moon's orbit widened, it gradually slowed Earth's spin to the 24 hours we experience today. In the early days, ocean tides on our young planet were much larger and more frequent. As the Earth cooled, water sloshing onto volcanic islands would have encouraged chemicals to mix, forming more complex prebiotic compounds. Moon tides, in turn, helped moderate and regulate the global climate by causing heat to flow from equator to pole. Without the pull of the Moon's gravity, Earth would likely wobble by as much as 80 degrees. Imagine if every few thousand years, as Earth changes its tilt, icebergs appeared in Ecuador and Senegal, and tropical beaches in Iceland and Siberia. From the record of impacts held in the Apollo rocks, scientists began to imagine that water ice may be trapped in the deep shadows of polar craters. With no atmosphere to transport heat, these shadowlands would stay cold for millions, if not billions of years. The first hints came in 1994. A probe named Clementine bounced radio signals off polar regions. The data were consistent with water molecules. Four years later, the Lunar Prospector picked up signatures of hydrogen associated with water at both lunar poles. In 2009, NASA's Lunar Crater Observation Sensing Satellite, LCROSS, aimed an impactor at Cabeus Crater near the South Pole, and then watched what was kicked up when it hit. The spectacular, unmistakable evidence of abundant water. Ancient lunar ice could be key to extending life beyond our home planet. Water is the enabler of space-based civilization, the far-reaching dream behind the Apollo program. NASA has announced an ambitious plan to return people to the moon. However, the agency receives less than 1/8 the annual funding it got during Apollo, which cost more than $110 billion in today's dollars. At the same time, private companies have begun to assume the mantle of space development. The techniques proven by Project Apollo are showing them the way. Entrepreneurs are investing now because they foresee a vibrant space industrial economy. And the businesses that will drive it are rooted in the enormous resources available on the lunar surface. At just 69 hours away by chemical rocket, the moon is our most likely extraterrestrial base. It has a natural power source, the sun. The sunlit lunar day length is equivalent to 2 weeks on Earth. A system of solar energy farms arranged around the moon's equator could supply constant power.
I'm picking up several pieces of really vesicular rock out here now.
Silicon and oxygen extracted from the soil could be fashioned into photovoltaic cells. Solar energy plants built of lunar materials could be ferried to Earth orbit or interplanetary locations. Solar-powered rovers could crawl non-stop around the moon. Apollo samples show the lunar surface is rich in metals for building: iron, titanium and aluminium, and fine silicon-laden dirt to make cement. Lunar prospectors will likely find gold, platinum group and rare earth metals. The 1967 United Nations Outer Space Treaty precludes any Earth nation from claiming the moon as sovereign territory. But it does not prevent private companies from staking mining claims. The body of law governing how the moon will develop is in its infancy. Government space agencies may at first lead the lunar reboot, but they probably won't manage it over time. A politically neutral body, a lunar authority, may be needed to guide the long-term vision and planning, and to keep the peace should a lunar land rush begin. Its dusty surface is a new frontier. The old moon made us what we are. Even as the memory of Apollo fades, the bright light of this new moon calls us to venture again to its shores and beyond.